Hello, my name is Summer Pappas, and this is my informative speech on 3D bioprinting. Across the world, many people suffer with failing organs, affecting their mental and physical health and causing families to be devastated when their loved ones aren't able to receive organ transplants in time. 3D bioprinting is a newly introduced technology with the ability to change medicine, holding the potential to create human organs on demand. We will explore how 3D bioprinting is performed, the challenges of 3D bioprinting, and the potential of 3D bioprinting. First off, let's discuss how 3D bioprinting works. 3D bioprinting is a process of using a 3D printer to create biological structures using BioLink made from living cells. According to Wenhu Li and others in 2023, 3D printing was first introduced as stereolithography by Charles W. Hull in 1986. This technique prints thin layers of a material in layers to form solid 3D structures during photochemical processes. BioLinks are made of stem cells or specialized cells, essential for building functioning tissues to mimic human organs. While 3D printing is very similar to regular 3D printing, it uses cells and tissues rather than plastic or metal. The process of 3D bioprinting is very complex. First, researchers scan patients by using medical imaging technology like MRI or CT scans. With the help of a scan, a digital blueprint of the organ or tissue is created as a precise match. The BioLink of the patient's cells are layered onto a support structure, allowing the cells to form a living organ. The materials and precision required for 3D bioprinting are detrimental to its success. According to Han Feng and others in 2023, 3D bioprinting technology as a customized and precise biomanufacturing platform can manufacture dressings and tissue engineering scaffolds that accurately stimulate tissue structure, which is more conducive to wound healing. The bioprinting process requires having precise control of environmental factors like temperature, oxygen levels, and nutrient supply. This ensures that the cells will survive and function properly. Now that we understand how 3D bioprinting works, let's discuss some of the challenges in the technology. There are many challenges faced with the technology of 3D bioprinting. One significant challenge is the complexity of replicating certain structures within human organs. According to Ki-Gu and others in 2015, tissue-engineered organs would be a source of organs for transportation in the future, but at present, there have been no acceptable artificial organs for clinical trial. While researchers are currently able to print simple tissues, it is much more difficult to print more complex organs like hearts, kidneys, and livers due to their more complex blood vessels and networks. Despite these complications in the development of 3D bioprinting, researchers are aiming to create vascularized tissue, allowing printed organs to function properly when surgically implanted in the patients. The cost and time that is put into 3D bioprinting is also a challenge. The costs for research and development are extremely high, making it difficult to spread worldwide. It also takes an immense amount of time to develop the bioprinting process, as you must create a BioLink to print complex structures and test functionality. In addition, expanding the technology would add to both the cost and time. Here are some of the other challenges of 3D bioprinting. The process of ensuring that 3D bioprinted organs meet the standards for proper functionality is very long and complex. By using human cells to create organs, ethical questions like who owns the bioprinted organs and how the technology should be used are raised. In addition, bioprinted organs have not been proven to function long-term, as this is a very new technology. While these challenges make it very difficult to continue the development and research of 3D bioprinting, it has been very promising. It has had very promising potential to revolutionize medicine. Let's discuss this future potential of 3D bioprinting. The technology of 3D bioprinting may be in its early stages of development. However, it is a very promising technology that may revolutionize medicine. According to Balters Leon and Stefan Richel in 2023, 3D bioprinting is a promising new method to create artificial organs and tissues. 3D bioprinting offers the precise spatial arrangement of biomaterials in cells to create 3D constructs. This technology can address the organ shortage crisis by assisting doctors in creating organs for their patients. This would make a major decrease in deaths due to organ shortages. Personalized medicine is another potential of 3D bioprinting. According to Antonia Yaneva and others in 2023, experimental research indicates that bioprinting holds the potential to fabricate various biological structures, including skin, blood vessels, cartilage, and even entire organs such as the heart and liver. 3D bioprinting has the ability to reduce the risk of transplant rejection. By using the patient's cells to create biolinks, the organ becomes an exact match for the patient. 3D bioprinting may also be useful in the testing of drugs in medical research. By testing drugs on bioprinted tissues and organs, the need for animal testing would be reduced. Researchers would have the ability to study the progression of diseases and organ function in a more controlled environment. This will lead to a quicker and safer drug testing process, benefiting the field of medicine. In conclusion, we've covered how bioprinting is performed, the challenges of bioprinting, and the potential of bioprinting. The future of 3D bioprinting is filled with potential and promise. While these challenges, continued research, and investment remain in the development, it will bring us closer to reality where organ transplants no longer require years of waiting, but are rather received in just hours. Thank you for listening to my informative speech.